So before we divide polynomials, I would like to do this. Because I know you know how to do this. And if I can get you thinking the right way how to do this, polynomials are going to be cake. And I apologize for saying cake when I don't have any to share.
I'm on a diet.
You're on a diet? Okay, good. All right. Not good. You don't need to be on a diet.
Water diet.
Okay, so what do I do? Like, what goes where? What do I put in different places? What do I do to do this problem?
I'm thinking you divide.
Yeah, I'm dividing, right? It tells me divide. So what do I draw? So I see several of you drawing it for me with your hand in the air. Do you know what this is called? Did you even know it had a name? I didn't until a couple of years ago. And someone asked me, does that have a name? And I was like, I don't know, let's search it up. And we searched it up and we found it had a name. It's called a vinculum. That's a dumb name. I know it is. I didn't make it up. Okay? So what goes inside the vinculum and what goes outside the vinculum? So 2735 goes on the inside, right, of the vinculum, and what goes on the outside?
17.
So what I'm dividing by goes on the outside, and what I'm dividing into goes on the inside, right? Okay, so what's my thought process here? How many times does 17 go into 2? It doesn't, right? So how many times does 17 go into 27? Once. And where do I put that 1? Above the 7. Do I have to?
Yes.
I don't, but it makes it easier if I do. Okay, it's not required to put it there. You might have been told that it is. It's not really required, but it makes the whole problem easier if you do. Okay, now what do I do with this number? I multiply it, right? 1 times 17. And what do I get when I multiply 1 times 17?
17.
And where do I put that number? Under the 27, right? And then what do I do with this number? Subtract. And now what? Actually subtract, right? And you get 10. So what from here? Bring down the 3. And like start over, right? I say how many times does 17 go into 103? What's 103 divided by 17? And we all know that's 6, right? We'd have an idea that it would be around 5 because if it was 20 going into 100, that would be 5, right? It's a little less than 20, a little more than 100, so maybe 6. Where does the 6 go? Okay, and what do I do with the 6? Okay, so let's see. 17 times 6, that's 42. So 102. So 102. And then what do I do? Subtract. What's 103 minus 102? 1. And then bring down the 5. What's 15 divided by 17? Or how many times does 17 go into 15? It doesn't. So 0. I also know I'm done, right? Because 17 doesn't go into 15. Normally, if I was doing, like, if I wanted an exact answer, I would put a decimal and add some zeros after it. We're not doing that today, so I'm not going to do that now. We're going to stop here, okay? But what is this number called? What? The remainder, right? So it's what was left over what I was originally dividing by. Does that make sense? You've been doing that for a while now, haven't you? I mean, to be fair, most of the time you get a calculator and press it in, right? Which is why I wanted to go through the algorithm with you to help you remember the steps that we do. Because our problems today look like the problem we just did. They look like it, but some of you are like, yeah, but it looks like it, but it's harder. What, just because there's letters it's harder? No, you'll be fine. Because who's going to help you? Yes, me. Okay, you ready? All right, what do you think I should draw first? A vinculum. Here's the vinculum. What goes outside the vinculum? X minus 4. And what goes inside the vinculum? Very good. Now, on this problem, I had to figure out how many times 17 went into 27. Well, 2 first and then 27, right? And mess with the whole number. I don't have to mess with the whole number here. I have to figure out what is x squared divided by x. How many times does x go into x squared? What's x squared divided by x? What is x squared divided by x? Remember, x squared is the same as x times x. So it's just x. It's just x. Where do you think I'm going to write the x? Above the where? Above the 8x. Why am I going to write it above the 8x? That's the like term, right? 8x and x are like terms. X squared and x are not like terms, are they? Okay. Now, is this required? No, but it's going to help us. Okay, it's going to help us. What do you think I do with this x now? Multiply it. But this time I don't just multiply it by the x. You know, before I was only messing with first terms. I multiply it by each of these two things. So what is x times x? X squared. And what is x times negative 4? Negative 4x. And what do you think I do now? Subtract, right? But here's the thing you have to be real careful of, is you have to subtract everything, right? I have to subtract this, and I have to subtract this. So what is x squared minus x squared? 0, right? Should I always get a 0 here? Yes, I should always get a 0 here, okay? Now this is weird. It's x squared minus a negative 4x. Oh, isn't it? Right? Isn't that plus? So when I originally made my subtraction sign, could I subtract that and then change that minus to a plus? Because I know I'm subtracting a negative. Does that make sense? Okay, so what do I do now? We said this is 0. What's this?
12x.
12x. And then what? Bring down your 1. And now what? Start over, right? So first term and first term. What's 12x divided by x? 12. Where does it go? Above the 1. And now multiply, right? What's 12x times x?
12x.
And what is 12x times negative 4?
Negative 48.
Negative 48. And now what? Subtract. Subtracting a negative makes a positive. This is 0. Should I always get a 0 here? Yeah. And this is 49. There's 2 ways to know that we're done now. Can somebody tell me one of the 2 ways? There's no more room at the top, right? There's no more numbers that I have a place for up here at the top. That's why it's helpful to put it above its like terms. When there's no more space for an answer, you know you're done. What's the other way to know you're done? Can I divide x into 49? No, I can't. Okay, so what is this called then? The remainder. So when I go to write my answer, I get x plus 12 plus my remainder over what I was originally dividing by. And that is my answer. Does that make sense?
Yeah. Yes. Yes. That's why now.
Ready for another? Okay. Let's try this one. 4x squared minus 13x minus 5 divided by x minus 2. Are you okay? Yes. So first I draw my vinculum. And what goes outside my vinculum? X minus 2. And what goes inside my vinculum? God bless you. Okay, so what do? Just first terms, right? 4x squared divided by x. 4x. Everybody okay with that? Where does it go? So 4x. And what do I do now? Multiply it by everything that I'm dividing by, right? So 4x times x.
4x squared.
4x squared. And then 4x times negative 2. It's not even only like negative 8x, it is negative 8x, right?
Yeah.
Okay, now what? Subtract. 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 What's this? 0. What's this?
Negative 5x.
Negative 5x. Am I done?
No.
Well, how do you know? I can still divide these two things and there's still room, right? So I'm going to bring down my negative 5. Now what? Divide. Negative 5x by x. Negative 5. Negative 5 times x. Negative 5x. Negative 5 times negative 2. Positive 10. Now I subtract. 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 What's here? And what's here?
5.
Negative 15. It's a negative 5 and a negative 10, right? Because I subtracted a 10. Now am I done? I'm not?
You gotta do your 4x minus 5.
Oh, you want me to write the answer? But am I done dividing? Yes. Okay, so what's my answer?
4x minus 5
Oops.
minus 15 over x minus 2.
Okay, so earlier when they said the answer here, they wrote this. Oops. Which one's right? Both of them, right? Because isn't subtracting the same as adding the negative?
Yes.
So do I care which one of these you write?
No.
I do not. Mm-mm. It doesn't make any difference. Yeah. Are you okay? Any questions? All right, let's do this one. Three x to the third minus 5x squared plus 2 divided by x minus 1. So first I draw my vinculum. Outside of the vinculum goes, and inside the vinculum,
3x squared plus 2.
That's me screeching to a halt.
Why?
That's a good question.
Why stop?
Does anybody notice anything weird right here?
We don't have a single x.
I don't have a single x term. Is that a problem? Yes, it is. Okay? If I start with an x to the third term like I do in this problem, I have to have an x squared term, I have to have an x term, and I have to have a constant. And if I don't, I have to add one in. How can I add an x term in without changing the problem, though? Add what? That's good thinking, but this is not an equation, so there's not really two sides.
You just gotta.
What's the only thing I'm allowed to add to anything that doesn't change its value? 0. So I can add a 0x.
What?
I said, so I can add a 0x. Does that make sense? If I start with an x to the third, I have to have an x to the third, x squared, x, and a constant. If I don't, I have to add one in there. The only thing I can add to a problem that doesn't change its value is a 0. So by adding a 0x, then I have my x term. Could I just go ahead and write plus 0 right there? Yes, I could, right? But by adding 0x, I see my x term, and it's a 0. Does that make sense? Any questions about that? Okay, so let's start. 3x cubed divided by x. You're right. Keep going. 3x squared. Does that make sense? Okay, where does it go?
It goes above your line.
Above 5, right? So 3x squared. Now what do I do? Multiply 3x squared times x. 3x cubed. 3x squared times negative 1. Negative 3x squared. And now? Subtract, subtract. What's here? 0. And what's here? Negative 2x squared. And now? Can I show you what I do sometimes, depending on the problem? I just go and bring everything that's left down. It's not required, but I just do it sometimes. Because sometimes, well, you'll see in a minute. You'll see why in a minute. Is that fair? Okay. Now what? Start over. Negative 2x squared divided by x. Negative 2x, right? Now this is, if you forgot to add your x term before, this is going to be the time you realize you forgot your x. Because why? There wouldn't be any term to write it over, right? Okay? So minus 2x. And now? Multiply. Negative 2x times x.
2x squared.
And negative 2x times negative 1. Positive 2x, right? Negative 2 and negative 1. Okay, and now? Subtract, subtract. So this is 0. This is negative 2x plus 2. And now? Start over. Negative 2x times x. And negative 2. And now? Multiply negative 2 times x and negative 2 times negative 1.
Plus 2.
Positive 2. And now? Subtract. Ooh. What happened?
Well, you got 0.
I got 0.
On both ends.
Okay. Now, this is a little foreshadowing for a couple lessons from now, but when we get a 0 as a remainder, what that means is that both of these things, this and this, those are called factors. Okay? That's just some pre-knowledge for later. Okay? But both of those things are called factors of what I was originally dividing by, or dividing into. Okay? So what's my answer?
3x squared minus 2x minus 2.
Yep, that's it. One more. Yes, sir. One more. You ready? X to the fourth. No reason to freak out. No reason to freak out because there's an x to the fourth, right? Because rule number 1 is what? Don't panic. So x to the fourth minus 5x to the third minus 8x squared plus 13x minus 12. So now that you know what we kind of have to notice up here, did you start counting down? Is there a 4? Is there a 3? Is there a 2? Is there a 1? Is there a constant? So do I need to add any terms this time? No. Okay. So did I just waste my time thinking about that? Absolutely not. right? Absolutely not. That's making sure that we're prepared before we even start the problem. So x squared minus 6 goes on the outside. X to the 4th minus 5x to the 3rd minus 8x squared plus 13x minus 12. Okay, so let's start. Talk me through it. X to the 4th
X times
divided by x squared is what?
squared.
So where are we going to put that? Of the x squared. Okay. X squared times x squared. Okay. And x squared minus 6. Well, that doesn't go here, does it? Under the like term, right?
Yeah.
Negative 6x squared. Is this okay?
No.
Yeah, it is. When I subtract and subtract, what's this? 0. What's this? Just negative 5x cubed, right? Negative 5x cubed. And then what's this?
2x squared.
Negative 2x squared, right? Do I need to bring something down? I already have 2 terms here. Before I only had 1. I do, right? I do need it, because you know what's going to happen. There's going to be an empty space, right? So do you see why sometimes I bring everything down? Okay. It's not going to hurt anyways. Now start over. Negative 5x to the 3rd divided by x squared.
Equals
Negative 5x, right? Negative 5x. So negative 5x times x squared.
negative 5x to cube root.
Negative 5x times negative 6. Positive 30x, right? Where does that go?
Under the like term.
Under the like term, so under the x term. And now? Subtract, subtract. This is 0. This is? This is?
Oh, that's negative 27x.
17. And then minus 12. So I just brought that down.
Big now.
Am I done?
No.
How do you know?
There's still
Yeah, there's still a spot up here. And can you divide x squared by x squared?
Yes.
Yes, so it's negative 2x squared divided by x squared.
Negative 2.
Negative 2. Multiply negative 2 times x squared.
Negative 2x squared.
And negative 2 times negative 6.
Positive 12.
Just 12, right? Not 12x, just a 12. And now subtract. Am I done? Why do you think some people think I'm not done yet? Because there's still an x, right? But remember what I'm dividing by. An x squared. I can't divide an x by an x squared. I can't simplify that, right? So my answer is just this. X squared minus 5x minus 2. And then plus negative 17x minus 24 over x squared minus 6, what I was originally dividing by. Questions? You good?